Hello, I've had a question in the 3 Physics Unit 1 Lesson 4. I'm looking at question number 5. In these word problems involving vectors, it's important that we draw the picture because we need to translate it into a series of vectors that we can make into algebraic vectors. And the only way we can do that is we need to know what the geometric vector looked like. So, starting with my northeast grid, it says the plane is steering a heading of north 20 degrees east at 300. So I'm going to call that my plane. So the pilot points the plane in that direction at that throttle speed. So north 20 east at 300 kilometers an hour. Now, make a note here. When we use the algebraic method, it always has to be the angle with the x-axis. So I'm going to say that's 70 degrees, and I'm going to cross out that 20 so I don't get confused and use the wrong angle. Next, it says a radar station reports that the plane is tracking. So this is where the plane's actually going, which means this is our resultant. This is what the plane is actually doing. It's actually doing north 40 east at 550 kilometers an hour. Now, it was north 40 east, which means we don't want that angle. We want the angle with the x-axis, so it would be 50 in this case. So I'm going to cross that 40 out because I don't want to accidentally use it. So our standard formula is the resultant equals the plane velocity plus wind velocity. But in this case, we know the resultant, we know the plane, and we're looking for the wind. So using algebra, we can rearrange the equation. We get the resultant minus plane is going to equal the wind, and this tells us how to stack our equation. So I'm going to start with the resultant. I'm going to subtract the plane, and what will come out of that is my wind vector. So the resultant is 550 cos 50 I plus, because they're both x and y components are positive in this case, 550 sine 50 j. The plane is 300 cos 70 I plus 300 sine 70 j. We need to remember we're subtracting these components when we plug it into the calculator. So when we do the 550 cos 50 minus 300 cos 70, we end up with 251i. And on the other one, 550 sine 50 minus 300 sine 70. We end up with 139.4, I guess. One decimal place there. So there is our resulting wind. We want to find what is the magnitude of that wind. So it's 251 squared plus 139.4 squared. And when we make that calculation, 251 squared plus 139.4 squared, I get an answer of 287. Just as a note, if the wind speeds are 287 kilometers an hour, it's probably not a good idea to be out flying. So I'm not exactly sure what this pilot was thinking. Tan inverse of y over x, tan inverse, so your y component, which is the 139.4 over 251. That will give us our heading or our bearing, so 139.4, 251, I get 29 degrees. So the wind at an astounding 287 kilometers an hour, so we're flying through a relatively large hurricane. For some bizarre reason, the x component's positive, so that's east. The y component's positive, so that's north. So the wind is east 29 degrees north. And when you compare that to the provided answer, we see that they have south 62 degrees west. And the reason for that, this is the way, in our answer, this is the way it's pointing All right, so let's just clarify that, just so you understand why it's different. The answer provided. So we're saying that the wind vector is pointing in that direction at 287 at an angle of 29. The answer given is actually where it's coming out of. All right, so they're saying it's 287, and their angle there was what, 60, 62? So they have 62 degrees there. All right, so pointing, and the answer here is out of. All right, on a test itself, I'm not going to be too picky on that. I'm quite happy because this is, this is telling me which way the vector's pointing. If you do a therefore statement saying it's out of and you put it in the other quadrant, that's fine as well. But in fact, you're getting the same answer. It's just how it's worded or reported. If you have any questions or follow up with that, let me know, and I will do my best to answer your questions.